Good morning, everyone. My name is Amy Gensel. I am a Systems Engineering Senior Manager with GDIT. Today, I have the privilege of sharing the stage with my customer, Arne Fleischer, Chief of the Operations and Engineering Branch at the National Institute of Allergy and Infectious Diseases, commonly known as NIAID or NIAID. Today, Arne and I are going to talk about NIAID's Cloud Journey, the abbreviated 25-minute version. Arne is going to talk about NIAID's mission, as well as why cloud is a good fit. I am going to talk about some lessons learned, as well as best practices, and also give you a high-level overview of the cloud platform that we developed for NIAID. And then we're going to come together at the end, and we're going to tell a couple stories about how that cloud platform supports scientific research.
Great. Good morning. Oh boy, that's loud. Good morning. So I'm sure everyone here is familiar with the butterfly effect. The legendary naturalist and late-night TV show host Stephen Colbert pretty much described it as a butterfly flaps its wings, and we all rush off to watch documentaries about butterflies, which is probably true, but of course what we're talking about here is a seemingly small or insignificant event occurring that has great significant causes throughout the world. I think that's something we really identify with at NIAID. If I was to have met you, we're going to pick a random point in time, let's say December of 2019. If I was to have met you, I'd probably tell you things about NIAID like we're one of 27 institutes or centers that make up what's collectively known as the National Institutes of Health. We're about the second largest in terms of staff and budget. And of course, our portfolio is about biomedical research in the areas of allergy and infectious disease. But if we met, I don't know, January of 2020 or February, but certainly by March, I'd be telling you a very different story. This, of course, is our director, Dr. Anthony Fauci, and while the COVID pandemic has certainly required us to shift and refocus our efforts on other things, that's not uncommon for us. We actually don't have to go back terribly far to see this. You may remember in 2016 Zika. This was a mosquito-borne virus that was of particular concern to pregnant mothers. There was 2014, the West African Ebola outbreak. There were actually Americans that were stationed there overseas, came back to the US to be treated. One of them famously was actually treated by Dr. Fauci at the NIH's Clinical Center. There was MERS, swine flu, bird flu, SARS, the anthrax attacks, West Nile, and of course, the HIV epidemic. And so, as I mentioned, we have a mandate to do biomedical research, basic and applied, in the areas of microbiology, infectious diseases, and immunology. But that's not what makes NIAID terribly unique. Many of the institutes have a similar mandate. We have an unusual thing. We have a dual mandate, and that is to respond rapidly to emerging and re-emerging disease threats. And so when we look at tools, when we're looking at technology, whether we're talking about cloud environments, we're talking about computational tools, we're talking about complex data sets, it is for the purpose of developing actionable data sets and products, healthcare decisions, and therapeutic interventions. This is to say, we are in the business, as simply put as possible, business of turning data into knowledge. And so we have to be successful, we have to value certain things. We value things like empowering and enabling our scientific researchers. You know, there was a time not so long ago when a researcher would show up at NIAID with pallets of IT equipment. We're talking storage arrays, we're talking computational nodes that would have to be unpackaged, racked, reconfigured, just so that researcher could start on their research. We value things like less operations and more engineering. Operations is great when you are trying to keep a site or system reliable, when you're trying to keep it secure, but operations doesn't deliver new features and functionality. And so we have to innovate quickly, and we have to keep that pace or match it with the scientific research. And so sometimes you can be the butterfly.
So when GDIT was tasked with building a cloud service offering for NIAID, before we dove too deep into the technical decisions, we spent a lot of time talking about how we wanted to consume cloud and the type of experience that we wanted to offer to our customers. We knew it was important to pay attention to people, process, and technology equally. And so I've picked 5 best practices that we adopted from those discussions that I'm going to highlight today that have had a positive impact at NIAD. So the first one is shifting towards a self-service, API-driven approach. So if you've ever done a value stream mapping exercise in your organization, you know you have an opportunity to visualize your process and see where steps in the process are optimized, but also be able to see where long wait times exist. When we did this for delivering infrastructure at NIAD, we realized that despite having implemented a lot of automation over the years, that we were still contributing to a lot of long wait times. We no longer wanted our customers to submit requests for infrastructure and then we respond by building it. Instead, we wanted to focus on creating tools and services to allow them to build and deploy the infrastructure on their own. So this meant sort of eliminating things like tickets and emails and phone calls and shifting towards creating a self-service consumable list, basically, of services. Not only did this best practice empower developers and researchers to consume services when they needed them and speed up delivery, but we also found that it freed up a lot of our time as well so that we were able to add value in different ways. The next one is the idea of infrastructure as code. So our commitment was to adopt infrastructure as code for everything that we did. This provides the ability to create reusable, maintainable, extensible, and testable infrastructure and easily and quickly share it. We were able to create a blueprint of our infrastructure that we can version control and treat like you would application code. Essentially, your entire data center can be documented in code, deployed the same way every time, like any day or night. The entire stack for NIAD is actually in GitHub. We also found that this would help reduce human error that you find through manual configuration that can sometimes lead to a decrease in reliability. And our commitment to infrastructure as code was so strong that many, many years ago, we decided that anyone that we hired at NIAD to work with cloud had to have previous programming experience. The third one is the idea of immutable delivery. So immutable means unchanging over time or unable to be changed. So with this, we really shifted our focus to deploying artifacts for infrastructure, so something like a container plus an application. And anytime there was a change that was required to the application or the container, the artifact is redeployed. You no longer change or update running infrastructure. You essentially destroy it and redeploy it. So some of the benefits of this, you're able to easily roll back to 100% known good state. And then you also avoid things like in-place upgrades and configuration drift that can sometimes result in your dev or QA or production environment being slightly misconfigured. The next one is the idea of continuous integration and continuous deployment pipelines. So this gave us an opportunity to essentially codify best practices. We were able to automate deploying infrastructure and applications, functional testing, security scanning, performance testing. This saves a ton of manually, potentially error-prone deployment work and results in a higher quality product. CI/CD also empowered our customers because they were able to control when they wanted to deploy changes and essentially eliminated us as a bottleneck. At NIAD, we have established stage gates in our pipelines. So we do things like security scanning for things like SQL injection vulnerabilities or cross-site scripting vulnerabilities. We also scan for static code scans. So we look for things like secrets that shouldn't be in there, as well as code quality checks. And in addition to supporting CI/CD for all of the applications we host, we also support CI/CD for the actual cloud stack. So our entire stack is deployed using CI/CD, so all of the AWS services, all of the APIs, all the custom microservices, even our documentation and training materials. And lastly, but certainly not least, is the idea of building a DevOps culture. So this really means increasing transparency and communication and collaboration across your development and operations teams. It's important to foster collaboration, innovation, and create culture for learning and sharing. As a leader, it's important to embody transformational leadership. So some of the things that we've been doing at NIAD include a webinar series. So we started many, many years ago offering this webinar series. We do it every couple of weeks. We've been averaging about 50 to 60 attendees, live attendees, because we do record every session and make it available afterwards. And we focus on things like deep dives into new AWS services or capabilities that we plan on releasing within the cloud platform. We've even invited some of our development teams to share some information about some of the applications and products and things like that they're developing. We also deliver a monthly newsletter, so we highlight things like some pending action items or, again, any sort of new services that we plan on releasing in the platform. And we have this section we call Bits and Bytes that we pull some blog posts or articles that my team finds helpful that they post to our For Reading Slack channel that we think would be helpful if we shared with the user community. We also have changed where we engage with our users through tools like Slack and Teams. We advertise office hours so we can try to connect and either answer questions or do brainstorming sessions. And then for us personally, we've also incorporated tools like Trello for managing our work in smaller batch sizes. And then we've tried some things that haven't been as successful. So I'd like to share this story as well. A few years ago, someone had recommended to me the book Accelerate, which I still personally find to be a very interesting book. And so we got the idea that we should do a summer book club. And so I bought a couple of books, and we advertised this to the user community, and people came in, and they were reading the books and things like that. And then we coordinated something at the end of the summer to get everybody together and sort of talk about what we learned. And I think we had 7 people show up or 8 people show up. So again, compared to sort of the 50 to 60 that we generally get for our webinar series, it wasn't that successful. I don't regret trying it. I think that's an important message to think about is, there's not a one-size-fits-all approach to shifting and adopting a DevOps culture. And then finally, I also can't strongly emphasize enough the importance of hiring the right people. So I think it's beyond looking for people that have the skills and the knowledge that you're looking for, but people who are open to learning and people who are committed to the mission of the organization. Because in my opinion, when you find people that care about the work that they do, it's really when some of the best ideas come about. So with our commitment to these best practices, as well as others that we don't have time today to get into, we set out on a journey to build a cloud platform for Naiad, and we named it Monarch. So what is Monarch? The answer to this question has changed a lot over the years. Today, we answer it by saying it's a custom software product that's developed and supported to help Naiad successfully use and develop AWS resources. As I've mentioned before, we emphasize people, process, and technology equally, so it fosters culture, processes, and modern approaches to IT infrastructure management, and cohesively ties a lot of COTS and SaaS products together so that we're able to offer a very streamlined experience for our user community. We currently have 2 service offerings. We call them the Docker PaaS and Spaces, and so I'm going to get into those a little bit. So the Docker PaaS was our first service offering in Monarch. It was really built around the idea of containerizing workloads and applications, and also following, I'm not sure if you're familiar with the 12-factor app guidelines. We sort of had this idea that if developers and researchers simply focused on developing their code in containers, that we could provide the easy, on-Rails experience for deploying and maintaining it. This particular environment is what we consider multi-tenant, so that we do host Docker containers for different researchers and different application teams, all within the same container orchestration platform. It does have that easy on-ramp for CI/CD, for automated deployments, and for security scanning. And it can also be interacted with our APIs and CLI and our custom web UI. So again, having a close feedback loop with our customers, we're able to sort of understand their needs, and we know that some of them value interacting with things via a web UI, and then some that also interact and prefer using command line. So we've been able to offer both. And as I said, this solution works well. We still offer it. We still host a lot of different Docker containers right now for the organization. But there's a few reasons why it doesn't work well. So we realized that containerizing applications actually was a bit challenging for some people. So people who have a lot of experience developing, in a VM or more of that type of an approach, shifting to do that within a Docker container was a bit of a hurdle for them. And then we also realized, in particular for researchers, again, they also struggled. So a lot of the research applications that we host are built on the rShiny platform, and there's a lot of sort of complicated dependencies with packages to make that work in a Docker container. And having a researcher try to work that through is really just taking them away from the research that they really need to be focusing on. We also learned that from our perspective, managing a multi-tenant PaaS space is challenging. Sorting out things like RBAC, and sometimes the Docker containers would have additional requirements, and so having to figure out how to build out those additional requirements within a space where you need to be careful and make sure that people aren't stepping on each other's toes was challenging and takes a lot of time. And then finally, this type of an approach, means that you're essentially missing out on a lot of the value and the services that AWS can provide. And it doesn't give us an opportunity to empower our research community that is savvy with things like AWS. So that led us to developing our second service offering that we call Spaces. So this one, like I said, is a single tenant space, so it's different than what we offer in the Docker PaaS. It opens up options for building cloud-native applications to take advantage of the depth and breadth that AWS offers. It also allowed us to offer a freedom with responsibilities model. So again, being able to empower researchers and developers who are savvy with AWS, but we could do it in a way that we could ensure there were guardrails in place for compliance with policies and security best practices. So in Spaces, some of our capabilities were able to easily and quickly provision bootstrapped AWS accounts. We offer RBAC as well as the MFA protected AWS protected access to console and programmatic credentials. And then that last bullet point is actually, is actually probably about a year's worth of work. We've been spending a lot of time focusing on building out a solution catalog so that we can provision common AWS infrastructure. And then we've equally spent a lot of time looking at building out an automated sort of dynamic compliance workflow within the platform as well. So, does anyone remember MTV Cribs? So stay with me here. I am going to connect this back to this. So it was a television show on MTV. In fact, it might even still be on, where a film crew follows around celebrities as they, show off their houses and sometimes their cars and sometimes their boats, but always the contents of their refrigerator. Because apparently the contents of your refrigerator reveals a lot about who you are and how you live your life. And so when Arna and I were preparing this presentation, I stared at this slide for a long time, trying to think about what I was going to say, and I just kept in my mind visualizing that I was opening the refrigerator door to show you the contents of the Monarch tech stack. So here's the inside of our refrigerator. You can see lots of different AWS services, and then the SaaS and COTS products that I had mentioned to you before. I'm not going to get into all of these. And then the bottom right corner, it's actually it's not proportional, honestly, to the value and the level of effort that we've put into this. That represents, again, a lot of the microservices and the custom APIs and the web UI and the CLIs, like everything that we've put into tying this all together to really deliver this dynamic platform for the organization.
So we'll go into story time now. Back in 2014, we launched a website called the 3D Print Exchange. You might remember in 2014, 3D printers were becoming more commercially available, and the scientific community really found a use for them. The thing was, there wasn't a place for researchers to share their models, and so we developed the 3D Print Exchange. Now, to say this was a niche website would be an understatement. Generally, it was filled with things like protein models and RNA models and things along those nature. It wasn't somewhere your kids would go and download a model of their favorite action figure or a fidget spinner and print it off. But something interesting happened in the early months of the pandemic. You might remember two things. There was a concern about a shortage for personal protective equipment, PPE. There was also a concern about ventilators, particularly parts for ventilators, for repairing them. And the 3D print community saw a real opportunity. And seemingly overnight, as you can see by the graph at the bottom there, our niche website was incredibly popular.
Yeah, and so on this slide, we're showing you a diagram of the 3D Print Exchange. And as you can see from the title, this is an application that we host in the Monarch Docker PaaS. You can sort of see there in blue, sort of off to the center, the container that we have that is hosting the majority of that application. It is behind a load balancer. We host all of our applications in the Docker PaaS behind load balancers. There's a variety of reasons. One of the big one is being able to do blue-green deployments without any type of downtime for the application. So as Arna was talking about, I'm not going to get into all the details of what you're seeing. And honestly, this is sort of a pared down diagram as well. But as Arna was saying, at the beginning of the pandemic, we suddenly saw this surge of users for this application that we had never seen before. And we did start to experience some performance issues. And so my team was able to huddle together with the development team, and we started kind of picking this apart, trying to figure out how we could fix this and what was going on. One of the immediate changes we were able to make was scaling up the RDS instance, which gave us a little bit of relief. And then we actually found, as we dug into it a little bit more, that the architecture was pretty sound, but there were actually some changes that were required within the application code in order to be able to support this increase in users. And so scaling up RDS bought the development team some time, and they were able to make the changes that were required and then deploy that. If I had shown you this diagram prior to that experience, you also would not have seen CloudFront. So CloudFront was a great fit, understanding what was happening right now with this suddenly being a worldwide resource and being able to sort of cache those models and make them accessible to people where they are located was a nice fit. And so we were able to develop a solution for CloudFront and add that in and give that to the development team, and they've been hosting it this way ever since.
So a second story for you. Back in 2015, NIAID started using a tool that's developed by the Broad Institute. It's called Seeker. It's a great tool for researchers. It actually easily allows researchers to take genomic data from an individual and do comparison on variants. And so, for example, we had the use case of we would look at someone with a very rare immune disease, and we might be interested in how the variations in their genome, how does it compare with a population? How does it compare with, say, their parents, for example? Where's the variation in the genomic data? Well, you may remember also, early into the pandemic, questions started to arise. Things like, why are some people more susceptible to COVID? Why do some people develop brain fog? Why do people get long COVID? And the hope is that we would find answers in the genomic data. The difference this time was we weren't trying to compare an individual against their parents. We were dealing with thousands upon thousands of genomes to analyze and find that variation.
And so this is a diagram of the data processing pipeline for Seeker at NIAID. And as you can see again from the title on this one compared to the other one, this is an example of something that we host in Monarch Spaces. You don't see a Docker container in this diagram. You could. We can host Docker containers, and we do host Docker containers in Spaces. But you do see a lot of cloud-native solutions. We have things like EMR, Elasticsearch, a lot of Lambda functions. So when we were originally tasked with building this out, we had a few objectives. One was cost. We wanted to be able to implement something that would only utilize the resources when they were needed. We didn't want to leave things running that weren't needed, as well as automate everything. And so that's what you're seeing here. There's a lot of automation with all the different Lambda functions. And then as Arna said, this application was suddenly now available to support COVID-19 research. And we actually, similarly to the 3D Print Exchange, hit a bit of a hiccup in that the genomes, not only the size of the genomes, but also the number of genomes, weren't fitting the Elasticsearch configuration that we had. And so this is an example of us partnering very closely with AWS. We had to lean in and work with a subject matter expert for Elasticsearch to sort of figure out that right configuration for cluster size and the number of nodes and things like that. And once we sorted that out, this was able to now support COVID-19 research.
So I hope we've been able to impress upon you the criticality and the challenges of the NIAID mission and how Amy's team has been able to meet and create opportunities for us to achieve our mission.
And I hope we've impressed upon you GDIT's understanding of the NIAID mission and how this cloud platform that we've developed supports the critical life-saving work that they perform every day.
Thank you.
So thank you.
And don't forget your surveys.
Yes, we're supposed to remind you to complete the survey.